Today we are going to look at numbers that we call squares and cubes. So we're going to start with finding the area of a square. These numbers are called what they are called because they have to do with squares. So I have a square with a side length of 2, and you know that every side of a square is congruent. So if that side is 2, that side is 2, and the area of a square is the base times the height or the length times the width. So 2 times 2, the area of this square would be 4 square units. Now, you tell me the area of a square with side length of 5. The area of a square with side length of 5 is 25. Now tell me the area of a square with side length of 7. The area of a square with side length of 7 is 49. Okay, so those numbers, 4, 25, and 49, they have special names. Those are perfect squares, and a perfect square is the area of a square with a whole number side length. So if you start a square with a whole number side length, the area you get is a perfect square. So the opposite of a perfect square, the inverse of a perfect square or any square number is the square root. A square root is the side length of a square with a given area. So the area is called the square number and the side length is the square root. The area is 25, that's the square number. The side length, 5, is the square root. So we're going to talk today about squares and cubes and roots. Roots are the inverses of exponents. They undo what exponents do. So like addition and subtraction are inverse operations. Multiplication and division are inverse operations. Roots and exponents are inverse operations. This is going to introduce for us a new symbol. And this symbol looks like a division house with a little check mark, okay? And that is called a root or a radical. All right, so that new symbol is what we're going to use to find the root of certain numbers. So we're going to look at this chart. We're going to fill out the square roots of these numbers. This is going to be very simple. Once we get going, you will fill it out on your own. So the square root of 1 means the area of the square is 1. And if the area of the square is 1, what is the side length? Well, 1 times 1 equals 1. So the side length of that square would be 1. The square root of 4 is if that square has area 4, what's its side length? Well, the side length would be 2 because 2 times 2 is 4. The area of 9, what times itself equals 9? Well, that is 3. 3 times 3 is 9. So you get the idea on this chart. Take a second and fill in the rest of the chart. That was easy, right? So the numbers under the radical, 1, 4, 9, 16, 25, 36, 49, those are the perfect squares. Those are the area of squares that have whole number side lengths. The numbers over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, those are the square roots. So the bigger numbers are the perfect squares, the smaller numbers are the square root. You need to be pretty familiar with all the perfect squares through 12. Okay, you need to know that 12 times 12 is 144. You need to know that the square root of 144 is 12. And some of you are already going to be familiar with these numbers, but those are the ones that you sort of need to know without having to think about. Okay, now what's important about squares and roots, or one of the things is that is important, is that every number, every positive number, has both a positive and a negative square root. Okay, and here's what I mean by that. Think about 36. What times itself equals 36? Well, 6 times 6 is 36, and negative 6 times negative 6 is 36. Okay, so 36 has 6 as its positive square root and negative 6 as its negative square root. And the way you'll know which one they want is by the symbol, by whatever's in front of the radical symbol. So the square root of 25 with no symbol in front of it, I want the positive square root. So what times itself equals 25? That's 5. If they want the negative square root, they will put the negative symbol in front of the radical. So the negative square root of 9, what times itself equals 9? Well, that's 3, but we want the negative square root, so that would be negative 3. Sometimes they want both, and you're going to learn this cool little symbol, this plus or minus symbol. That means positive or negative. That means I want the positive and the negative square root at the same time. So the positive square root of 64 and the negative square root of 64 are 8 and negative 8. And the way I write that is plus or minus 8, and that's how you read that, plus or minus 8. It's also important to note that you can take the square root of fractions. So if I have the square root of 16 over 81, I can do the square root of 16 over the square root of 81. The square root of 16 is 4. Notice I want the positive square root because there's no symbol written in front. And the square root of 81 is 9. And you can check that 4 ninths times 4 ninths equals 16 over 81. Square roots are not the only roots. Notice here that I have a radical symbol, but I've got this little number, this little 3 in front. Well, that means I want the cube root. I want what times itself 3 times is 64. That number there is called the index. That number is the index. 3 is the index. And notice over here it tells you that if the index is not written, the index is 2. So when we see this, we want the square root of 64 because there's an understood 2 there. We don't normally write it, but it's 2, okay? The number under the radical has a fancy name. It is called the radicand, okay? So if we want the cube root of 64, we're trying to find what times itself 3 times is 64. What times what times what is 64, and that happens to be 4. So the cube root of 64 is 4. And just like square roots are named because it's the areas of squares and side links that we're looking at, cubes and cube roots are named because they're looking at the volume of cubes. Look at this cube here. It has a side length of 3. Well, that means this length is 3 and this length is 3. So the volume of this cube is 3 times 3 times 3, which is 27. Okay, so 27 is called the perfect cube because we started with a whole number, and 3 is called the cube root. The side length is the root, the volume is the cube. So here is a table with the first 10 perfect cubes and cube roots. Cubes get big really quick, and so we don't go very far with them. You won't see many that are over this, but these are the ones that you sort of need to be familiar with. Here is something interesting about roots that, well, you may find it interesting or you may find it terrifying. Roots can be written as exponents, and they are written as fractional exponents. Everybody's favorite thing, a fraction. So we came into 8th grade knowing about positive exponents. We learned just recently about zero exponents and negative exponents, and now you're learning about fractional exponents. So here's how it works. If I have the square root of 25, remember the index here is a 2, even though we don't write it. I can write that as 25 to the 1/2 power. So the 1/2 power means the square root of that number. If I have the cube root of a number, notice my index is a 3. So the cube root of 125 can be written as 125 to the 1/3. So if you see a fractional exponent, that means we're dealing with the roots. And what's also kind of interesting, of course, I'm the math teacher geek, but these fractional or rational, remember, rational often means can be written as a fraction, they follow all the exponent rules that we have learned. Okay? So, what do I mean by that? Well, 27 to the 1/3, this isn't really going to be a rule. This is just how we would use this. 27 to the 1/3 power means the cube root of 27, and we can use our chart or just figure it out on by ourselves, and the cube root of 27 is 3. 3 times 3 times 3 is 27. Now here I have a negative fractional exponent. So what do I do with a fraction? I'm sorry, let me start over. What do I do with a negative exponent? What does a negative exponent mean? It means I take the reciprocal, right? So 121 to the negative 1/2 means 1 over 121 to the positive 1/2, right? Well, that 1/2 exponent means the square root of 121. And so this is 1 over the square root of 121 is 11. Okay, look at the next one. Here I have 9 to the 7/2 times 9 to the negative 3/2. Now notice I have something besides 1/2, and how this works, and we're not going to do a whole lot with this, but the top number is a power. Okay, this means 9 to the 7th power, and then the bottom number is a root. I want to take the square root. Or I could say the square root of 9 and then raise it to the 7th power. Here I have a fractional exponent is 2, that's a square root. The numerator is 3, that means I want to take it to the 3rd power. But what I want to show here is that I'm multiplying with the same base. When I'm multiplying with the same base, what do I do to the exponents? I add, right? So I keep the base and I add 7/2 plus a negative 3/2, right? So 7/2 plus a negative 3/2 is 4/2. Notice that that simplifies. 4 over 2 is 2. So this is really the same thing as 9 squared, which is 81. So that's a little more in depth than we're going to get, but I wanted to show you how that multiplying with the same base, how that product rule worked. One more. So here I have 27 to the negative 1/3 raised to the 3rd power. Notice I have a power to a power. What do I do when I see a power raised to a power? I multiply the powers, right? So I'm going to do 27, and then when I go to the side here, negative 1/3 times 3 is what? What is negative 1/3 times 3? It's negative 1, right? So this is 27 to the negative 1. That's a negative exponent. So I'm going to do 1 over 27 to the 1st power. So anything you can do with a whole number exponent or a negative exponent, you can do with a fractional exponent.